we discuss about the octahedral void and the tetrahedral void, how they are formed during the packing of a solid. In this video, we will going to discuss about how this octahedral void and the tetrahedral voids are located in cubic crystal system. Before we move further, if you like my videos, then subscribe the channel and like the videos, share the videos and press bell icon for more videos. First, we start with the location of tetrahedral voids. There are two tetrahedral voids for each sphere. If in CCP, n is the number of sphere or atoms are present, then total number of tetrahedral void per sphere is equal to 2n. In bracket here write as 2 TV, that means 2 tetrahedral voids per sphere. As we know, CCP structure has 4 atoms per unit. Thus, the number of tetrahedral voids is equal to 2n, means 2 into 4, that is equal to 8 tetrahedral voids. Let us consider a unit cell of a CCP or FCC lattice. It has atoms at all corners. As well as in the center of 6 phases. If we see carefully, we observe that the unit cell has 8 small cubes. Each small cube has atoms at alternate corners. In this diagram, these are the 8 cubes. If we consider a single cube out of this 8 cube, then we see that the atoms or the spheres are present at alternate corner of the cube like this. In this picture, these spheres are present at alternate corners here, here, here and here. When these 4 atoms are joined together to form a regular tetrahedron like this, here tetrahedron is formed here. The center of the small cube is a tetrahedral void. Thus, there is a one tetrahedral void in each small cube. Since there are 8 small cubes, here we see 1, this is 2, 3, 4, 8. Again we see 1, 2, 3, 4, 5, 6, 7, 8. 8 cubes are there, and each cube consists a sphere or the atom on its corner alternately, and each cube consists of one tetrahedral void. Therefore, 8 cube consists 8 tetrahedral void. Therefore, the number of a tetrahedral void in a CCP is equal to 2n, that is equal to 2 into 4 is equal to 8 tetrahedral voids. Here we count 1, 2, 3, 4, 5, 6, 7, 8. And this moving diagram shows the tetrahedral voids. Now, we move to location of octahedral voids. Let us consider a unit cell of a CCP or FCC lattice. It has atoms at all corners of the cube and at the center of each face. Again, if we see carefully, we observe that the body center of the cube is not occupied, but it is surrounded by the 6 atoms on center of 6 phases. Like this, 4, 8. This orange color spheres are present at the corner of the cube, and this white color, this light blue color, are present in the center of each face. These are 6, and this the sphere which are present at the corner are 8. That means total 14. Then if we join this sphere which are present in the center of the 6 faces, then we found that there is a formation of octahedral shape like this, and that octahedral shape is nothing but the octahedral void. It means that in the CCP or the FCC, one octahedral void is present inside the body. So octahedral void at body center of the cube is equal to 1. In addition to body center, there is an octahedral void at the center of the each edge. Thus, in CCP, unit cell, here we see how the octahedral void is present in the center of the each edge of the cube. Here we consider the FCC or the CCP. Then we consider this part of the cube and this edge, this bold one. Then here we arrange the cubes like this, and spheres are present similar to this cube. That means at the corner as well as in the center of the 6 faces. So these are the face-centered spheres or the atoms. If we join them, then again octahedral void is formed. And as we know, in the cube, there are 12 edges, and each edge is contributed by the 4 unit cells. Octahedral void at the edge is equal to 12 edges into each edge is contributed by the 4 cube, therefore 1 by 4, that is equal to 3. That means the octahedral void present in the CCP or the FCC structure, that number is 3. Thus, in CCP structure, one octahedral void is present at the body center of the cube, and 3 are present at the edges, center of the edges. It means that total number of octahedral voids 1 plus 3, that is equal to 4. Here represent the 12 places where these octahedral voids are to be located. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As we know, in CCP structure, each unit cell has 4 atoms. Therefore, the number of octahedral voids are same as the number of atoms. That is, number of octahedral voids is equal to n. That is 1 octahedral void per sphere, as in CCP, or CCP volume is a 4. So, there 4 octahedral voids are present. Then, next, we discuss about the radius ratio rule. Then, what is radius ratio rule? The ratio of a radius of a cation to the radius of an anion is known as radius ratio of the ionic solid. Radius ratio rule is applicable in ionic solids. For the stability of an ionic compound, each cation should be surrounded by maximum number of anions and vice versa for electrostatic force of attraction. In ionic compound, the number of oppositely charged ions surrounded each ion is called as coordination number. Means, in ionic compound, cations are surrounded by the anions or vice versa. Since ionic bond is a non-directional, the arrangement of ions with the ionic crystal is determining the size of the ions. Then, the radius ratio rule is useful in predicting the crystalline structure of ionic compound. And it is represented as radius ratio is equal to radius of cation divided by radius of anion. The structure of ionic compound depends upon the stoichiometry of it and the size of ions. Greater the radius ratio, greater is the coordination number of a cation. From the radius ratio, the geometry of unit cell depends upon the coordination number of a cation and anion. That means here, from the radius ratio, we determine the geometry of the compound also. Here, the radius ratio rule for every type of a crystal structure with their coordination number and crystal structures are discussed. Here, a table is there, that is the radius ratio, coordination number, crystalline structure, and the examples. Now, first, radius ratio range 0.155 to 0.225. The coordination number becomes a 3 and its crystalline structure plain triangular, for example B2O3. The next one, radius ratio range 0.225 to 0.414. Coordination number becomes a 4. Shape tetrahedral, crystalline structure tetrahedral. Example ZNS, CuCl, HgS. Then next 0.414 to 0.732. Coordination number becomes a 6. Crystalline structure is octahedral. For example, NaCl, potassium bromide, and HgO. Then next one is the 0.732 to 1. Coordination number becomes 8. And crystalline structure is a cubic. For example, cesium chloride, titanium bromide, titanium chloride. And last one, when the radius ratio becomes 1 and then the coordination number becomes 12, and when the coordination number is 12, then definitely crystalline structure is the SCP or the CCP, for example magnesium. Here we discussed about the location of a tetrahedral void and the octahedral void in detail along with the radius ratio. Thank you.